好，同学，我们回来了哈。我们来这一小时，我们要来看一下 code。好，这些 code 都是真实可以用的哈。其实，我们实验室自己在做一些分析的时候，我们也有用个 code。那 code 当然是Google 在 TensorFlow 上提供的哈。Okay, this hour will take some time to look at the real world code used to analyze text. Okay, those examples are provided by TensorFlow or Google. Actually, in my lab, when we analyze security logs, we still use exactly the same code. Okay, so let's take a look at this one. Okay, but before that, I would like to introduce a very important concept, which is called TensorFlow Dataset, which is right here. Okay, right here, and I think it's important. One might be one of the important things before you analyze your data. You have to clean your data up to place your data in a very nice structure. So basically, TensorFlow has such kind of data structure to help you to manage your data set. So it is called TFDS, TensorFlow Data Set. Okay. There are a lot of data sets, okay, well-known data set. For example, M18-3, which is the digital handwriting, or there is some movie comment data set which is called movie length. Those very well Titanic, okay. There are some very famous well-known data set, okay. So TensorFlow has collect all those data set and put them into a very useful data structure, which is called TFDS. So here you can see that there are some public available data set which already be organized by TensorFlow. Okay, so take a look at this one. If you need audio data, there are some well-known data set. There are some data set right here, graph, images. So we can see that you can see what images. Okay, images. For image classification, so you as far as I know, C4, that is the data set we introduced before. And here's the MIST, an extension of MIST. And here is MMIST right here. MIST corrupt. There are a lot of different data set has already been organized, processed by TensorFlow. So basically, you don't have to collect those data by your own. You simply just use one simple line to download the data provided by TensorFlow and use them. And that's all. You don't have to worry about how to handle those data, and we will teach you how to do the further analysis using TensorFlow dataset. Okay, in the following example, here's object detection, question answer. And this question answer is specifically for text-based data. Okay, ranking data recommendations, something like that. There are a lot of different data right here, so especially some text data right here. Okay, most of them are collection from Wikipedia or some corpus or some IMDb reviews, which is the movie review data, something like that. Okay, there are a lot of data. Okay, I think it sometimes it's worthy for you if you want to know how to deal with those data, how to analyze different type of data. It's worthy to start from here. Okay, that is just the data already be collected and analyzed and well organized by Google. There are a lot of data right here, but right here is for example, I collect a lot of packets. I collect a lot of PE files, but they are not in TensorFlow dataset, right? So how do I create a TensorFlow dataset compatible dataset by using my own data? And then I can use some very useful tools or an analysis mechanism or algorithms, directly apply them on the TensorFlow dataset, which is more convenient for you. Okay, so I will show you how to do that. 好，中文就是说，TensorFlow 有提供一个特别的 class 叫做TDFS，那里面其实里面已经有一些直接很 well known 的那些 dataset 已经被整理过了，那它是以这个形式出现的。那你在用它的时候，只要下载，它就已经用了。里面不管是 labels 啊，那些数值啊，都已经帮你处理好了，所以我们就不用自己很手动的，比如说去找手写数字啊，然后或者说找评论啊，找什么的都不用，你就直接下来就好了。那现在的问题就是说，这些东西都已经整理好，这些都是 well known 的。那我们会有一个需求是，我们有一些自己想要分析的风暴啊、log 啊、P 档案啊，它不是这个形式的嘛，对不对？我们还是就像你在写作业的时候，我们老师会给你一些 Pico 档或是一些 CSV 档嘛，对，可是那都不是很正规。比较正规的方式是应该把它变成 TDFS，那你就下载，然后就直接 apply 在你的 neural network 里面，就不用对资料的前处理或者是 label 做太多的事情啊。所以我们现在要教你怎么样做，把你自己的资料变成 TDFS，然后我们后面才会跟你讲说怎么做，你怎么把 neural network 直接 apply 在这个 TDFS 上面。Okay, so the example I would like to show you right here is here. I have three different example right here, all provided by TensorFlow. The first one is basic text classification. It is a neural network. Okay, and the second one is text classification with RNN. Okay, it is I think it's the LSTM and LSTM and GRU, something like that, and it's classified text with BERT. Okay, three of them are all provided by TensorFlow. So you can simply just open those files, and you can see that there is a run in Google Colab. So you simply just click it, and it will open the Colab for you, and you can save it in your Google Drive, and just run it. Okay, so let's take a first look at the basic text classification. Okay, I can turn it off. Okay, will that be better? Okay, I think that would be better. Okay, so this tutorial will do text classification. Okay, on IMDb dataset. So it looks like this. Okay, I'll draw a quick figure. Okay, so it likes this. I have a lot of movie comment, so they'll be like this. Movie comment, and I want to fit into certain classifier. Right? And the classifier will output either, it is a binary classifier, okay? It is either 0 or 1, that is a positive or a negative comment. So that is a very simple task, right? Very simple task. Okay, let's go back. So of course there are some libraries you need to import. Okay, we simply just skip them. Okay, when we talk about it, this task is called sentiment task. So it is a binary or two class classification. Okay, so the data is from somewhere. Okay, it has some movie review, movie comments. Okay, from IMDb, which is a database. Okay, so we have 25,000 reviews for training, 25,000 reviews for testing. Okay, so originally, this data is a file. So you can download the file. Okay, then you can see that. Okay, you can simply just take a look at this this data set. Okay, did you notice that this data set, okay, TensorFlow used a very nice function set tf-keras utility get file, and that is the file name. Okay, that is how they create this dataset. Okay, and before we jump into the code, okay, let's take a look at the dataset. The dataset, basically, they are text file because they are comments, they are reviews of movie, right? So here is the main directory. So it can be any arbitrary directory, okay? And if you have different classes of data, then the subdirectory right here, you see that? Class A and class B. No matter what kind of name it is, as long as they are different, okay? That is the class name. So the first class is class underscore A. The second class is class underscore B. And that is your label. And then under that subdirectory, you put your sample in the directory. Each sample is represented as one file. So for example, atext1.txt, it is a file that represents a data under class A. And if you have multiple samples under one class and you continue use like that, the name of this file name is not important as long as it is under subclass class A. So again, if we draw it in a more reasonable, that means you have 1, 2, 3 to n, and you have y, right? That is class A, B, 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 and that is the features right here is in the file. Okay, is in the file. So but what exactly the file should be? Usually when for example, take this example, okay, take this IMDb example. There are comments, right? So the comments, you simply just put the sentence of these comments in that txt file. So if you have, I think it says we have 25,000 reviews for training, right? And but we don't know how many of them are, they say, equal number of positive and negative reviews, right? So in total, you have 50,000 reviews, 50,000, okay? So we have two classes. One is positive. You just name the class A as positive and class B as negative. And for each name, there are 25,000 reviews in each class, right? Because they are evenly, right? We are 25,000. So in total, there will be 50,000 files in that directory. And in each file, there are the comments. Okay, for example, it's take a here is an example. There are a very long comment. That's okay. You just simply put all those text in the txt file. So it says someone wrote and direct this award-winning short film, blah blah blah. That is the comment. So in this example, we demonstrate how to organize your text-based dataset in this structure, directory structure. Okay, is that okay? So if we collect a lot of system log, for example, part of them are attack logs for attack, and other logs are normal logs. So you can simply just name a directory, and that is called attack, and the other subdirectory named normal, and put all the logs you collect in a text file. So maybe inside that means time, date, and information, and the logs you write, and a single line in a text file. And the other one is another log file at different time, different date, and you put it in the second text file, and so on and so forth. Depends on how many logs you have. and put them in such kind of directory. Okay, so after you prepare those kind of directory, and you simply call this specific function text data set from directory. Okay, I think it's right here. Okay, the definition is right here. You can simply just find it in the Google. Okay, it says it is a Keras function, very convenient function for you. You can convert your data set from the directory data structure to a TensorFlow DS. Okay, so you have to provide the main directory right here, and here labels equals to infer. Okay, the definition is right here. Definition is right here. The infer says the name of the subdirectory is exactly the label's name. So in this case, sorry, where is it? And in this case, if you use inferred, that means class A, this subdirectory name, is exactly the label's name. Okay, and you have two subdirectories, so you have two labels, two Y. Okay, and then here we say label mode integer, int. Int means the definition. Sorry, the definition is right here. If it is integer, it means the labels are encoded as integer. So for example, class A will be encoded internally as 0. Class B will be encoded internally in the data set as 1 and 2, 3, 4, so on and so forth. It depends on how many labels you have. Okay, so that is integer. And that makes your table looks like, actually that is 0, 0, 0, 0, 1, 1, 1, 1. If you have a class C, then that would be 2, 2, 2. Something like that. So when your Y looks like an integer, then you have to figure out very important things when you design your neural network, such as this. That is big X, right? So we have some hidden neurons right here, right? And make sure if you have index as your Y, usually we will further make it as a one hot encoding, right? So basically, if you have 3 indexes in Y, actually it means 1, 0, 0, okay? And 1 means 0, 1, 0, and 2 means 0, 0, 1, right? Because that's exactly the index you use in the one hot encoding. So basically, you have 3 neurons at the end of the output, which is Y. Right? Am I clear? So basically, okay, you do such kind of things. And if you apply softmax at the, I think you should apply softmax at the end of this Y. So it will become, more generally, it will become such kind of things. It will output a vector, only 1 neuron, but it had 3 vectors. But it passed softmax before when they do such kind of output. So it will output the probability, right? So for example, it's 0, 0, 1, 0, 0, 95, 0, 0, 4. So that when you do argmax, right? So the answer is 2. Sorry, then there's 1. 1. Now that's 0, 1. The index is 0, 1, and 2, right? So argmax is 1. So that means the result is 1. So that you have to very carefully choose what kind of mechanism you use in your neural network. So you know where exactly you want to use that is integer right here, because you have a integer label. And if you have an integer label, the loss function you should use is sparse cross entropy. Okay, am I clear? Okay, if you use index, okay. However, if your data set is categorical, that means I use another color, okay? Categorical, that means I use another color, the red one, okay? So the black is integer, and it infers use sparse, categorical, okay? And if you use the red one, it is a vector, and you should use categorical cross entropy. So if you are a red one, that means your y is originally, okay, your y is originally encoded as vector. You don't use index as your y. So originally it was, maybe it was already encoded as such a something like that, the red one. So you don't have to convert it into another y, because it's already been represent as the vectors. So at the end of your neural network, you don't have to do argmax. You don't have to do you need only one neuron. Sorry. You only need one neurons. And even you don't need softmax, okay? Okay. So in this case, you directly output something like that. Okay, and you don't even need the upper argmax to do to determine which index it is. You directly output, and in this case you use categorical cross entropy. In red ones you use categorical cross entropy. In black ones design you use sparse cross and categorical cross entropy. They are a little bit different, and they are all mentioned right here. So make sure you read all those things before you create your own dataset. Okay, so you know you have to provide a directory, and your subdirectory is the label's name, and you know what kind of which mode you use. It depends on what kind of output data you want to use. Okay, and the batch size is 22. So for every time your system to fetch a batch data, it will be include 32 samples. Okay, so it's very convenient for neural network to do, because neural network can fetch a bunch of data to do mini batch processing, right? To mini batch training, right? Okay, and then shuffle true. That means when you create this data, okay, although you have a very nice structure like this, right? And you have the first file, second file, third file, but the shuffle means you simply just shuffle all the data. So the sequence, the order of the file name is not important, because they will shuffle before they create the data. Okay, and then there'll be seed. If you shuffle the data, you can use a seed. If you use the seed every time, if you use the same seed when you create the data, the shuffle result will be the same. If you do not use the seed, the shuffle will be totally random. Okay, and here is the validation split. That means how much data you would like to use when you do validation. So usually we use, for example, 20% of data as the validation data set. So you can simply just put it right here. So afterward, when you use the data set, and you can use a very simple line to extract only 20% of the data as the validation data set, and the rest of it 80% as the training data set. Okay, you can simply just, and then they will be separated. So the validation data set will not be used in training. Training data set will be used for training. Okay, so in this case, you can simply just use this very I think it's right here. Right here, you can simply just input the file, the directory you have, how much data size, how much page data size you want to use. In this case, is 32, and how many data set you would like to do for splitting, that is 10%. Okay, and then and the subset right here is a little bit subtle. So please take a look at this explanation right here. It's right here. The subset can only be one of the training or validation. It's a string. So that means when you write training right here, that means the data set you created right now will contain, look at this word, will contain 80% of the data. Okay, and will be used as the training data set. Okay, the name is raw training data set. It's right here. Okay, so if you want use the 80% of the data, so you have to write training right here. And if you want to use the rest of the 20% of data, which is specified right here, and the word you have to put in this parameter must be validation. Okay, must be validation. So basically, you can simply just prepare your data set in this way and use a very simple function to create your data set, and then your data set will be prepared in TFDS structure. Okay, so how did you get those data? Okay, so it's quite simple. You use take, and you have a parameter 1. That means take one batch of data. So here is an example. You can simply, because the batch is, I think it is 32. So in this for loop, 32 data will be fetched from your data set. Okay, but however, in here, okay, it only shows the first 3. So you can see that for each time you fetch a batch of data, okay, 2 output will be returned. The first one is the data itself, and the second one is the labels. So for this 32 data, okay, the data will be this one, the front one. Okay, so it'll be like this. And the label data here will be like this one, 0. Why it is 0? Because as we mentioned before, when you create this kind of data, by default, the infer, which is here, right here, the mode, the label mode is in int by default, and the labels is inferred by default. So even if though you don't write the parameter right here in your code, but by default they are inferred and int. So by default, the name of the subdirectory will be the label's name, and the label will be encoded starting from 0, 1, 2, 3, 4, 5, etc. Something like that. Okay, so you can see that if you would like to know the exact name of the corresponding label 0, you can simply just call this value, and you will say, okay, the name of your directory is neg, negative, and positive, POS. But the internal label index is 0 and 1. So that is it. Okay, so you can do that again. I would like to create another dataset, use the rest of the 20% of data. So you put validation right here. So this dataset, row validation DS has 20% of the original data. Okay, so that is, if you have another dataset, you can simply just call the dataset and use another input file. So that is another file, another dataset. So in this case, we have three. It comes from two datasets, training and testing. But in the training dataset, we split it with 20%, 80%. So 80% of the training dataset will be training dataset. 20% of the training dataset will be validation. And the entire dataset of test is right here. It's right here. Okay, will be used as the testing dataset. It says row test DS. Okay, after you have all those datasets, this is quite clear. Okay, so basically, there are texts, right? So we are trying to do a model to analyze text. And then, as we mentioned before, it is a sentimental task, right? And I think it's right here. It is a sentimental task. The output is either 0 or 1, right? So basically, let's take a look at the model. I think that will be very convenient for you to see the model right here. Right here. Okay, it is a neural network. It's a sequential model. So the first layer is an embedding layer, right? I will talk about embedding layer later. Okay, it is there are some code right layer. Okay, so then it is dropout layer and it's pooling layer, but it does not use max pooling. It is a simple average pooling. And dropout again, and here's the dense. The dense 1 means only output 1 neuron, right? So, and after that, here is the compile, right? We have to compile the model. So basically, because it is a 1 and 0, it's a binary classification. So it use, and we select index when we create, we select int when we create this dataset, right? So it will be encoded as 0 and 1, and it has only 2 classes. So we use binary cross entropy as the loss function. Okay, and the metric is the accuracy. Okay, so here's a very important thing is that from log it equals 2, that means they don't write specifically the softmax in the lay model. You can see that the last layer is dense 1 to output one word, one value, right? However, they do not, in this model, they do not apply softmax, right? So if you do not apply softmax, please write from log it equals to true right here. Okay. However, if you write activation equals softmax, something like that. If you really specify what kind of activation you want to use right here, like this, then here you simply just says from log is equals false. You have to understand that that is how it works. Okay, so basically, because the example do not to write it specifically by using softmax, so we keep it like this original way. So they do not apply softmax right here. So the optimizer have to apply softmax right here. So true means I will help you to add one additional softmax layer after your dense network. So that is okay. So the optimizer is Adam. The matrix is binary accuracy, and then here feed. Okay, you have training data, you have validation data, you have Apex 10. So just run. So at the end, we can evaluate the model using the test DS. You don't have to specify how many Ys, how many different. As long as you create the test DS, TFDS, and you simply just feed them into your model, and the result will be like this. And then here is the result, just like that. And we can plot the result right here. So basically, you don't have to handle all the data set inside the data set. You just organize your data set, your data, in a well-organized structure. Main directory, your labels, and for each text file, you include your text in your text file. Okay, that's it. So that's quite simple. So if you want to change your model, you don't have to deal with the data set. You simply just modify the model right here to, for example, to a more complex model, RN, CN, something like that. Okay, that's it. I think that is what we are talking about right here. So next week, we will further talk about more complex models, but you don't have to. Sorry. In the other example, the structure is always exactly the same. They create the dataset by using the directory, and they don't have to do any labeling things because label already labeled in the dataset. They split the data into 3 different sets: validation, test, and the training. And then you directly, so you can focus on designing the models right here. So at the second and third example, they have, I think it's convolutional neural network model, and the third one is a language model, BERT model. But the data preparation phase is exactly the same. They all create TFDS by using the structure. So we will talk about the difference between 3 models. This model has a very specific called embedding. We'll talk about later. And this one we can pick the model used in the second experiment. It's right here. The structure is a little bit different, right? It has embedding too, but it has a bidirectional LSTM. And the third one is exactly the same, but the model is a little bit different, like here. Okay, it's a little bit complex. So we will talk about it next week, and then we will show you another example about how do we do anomaly detection using the same structure. Okay, that's it. Okay, so no matter you are English students or student who in Taiwan, so make sure you are online, or you still take some time to see the video on demand on YouTube. Okay, that's it.